water, wash your hands, take a shower. And this may go over and over again. You maybe have to do this for about 10 to 15 to 20, maybe 30 minutes until you reach that magic number, and then you're back to baseline and your anxiety has been alleviated by the repetitiveness of your behavior that sort of magically makes it go away. Again, this in the fears that you can see here, spending 30 minutes off of something like maybe there's some sunflower seeds on the ground, and for somebody who has COCD, they envision that it's a dump truck full of manure on their living room table. This is not something that will be conducive to function in the long term if they have to spend over and over again to alleviate these obsessions and compulsions that they have. So I would like to sort of like mention this because this is something that we see within the neuroscience research, is that there is this connectivity between sensory subcortical to cortical pathway, and it's involved in a wide array of disgust-based experiences. And in our example of like sunflower seeds, that may set somebody off, but these other examples may set other people off. So some of these examples are not necessarily pathogen-based disgust, but many of them are, like looking at parasite infestation, smelly gym shoes. This would invoke a pathogen-based disgust. But what's fascinating is if I were to ask each person, like let's say you're in a living room with your friends, or maybe you're in a classroom listening to this, or maybe you're walking around town, or whatever the case may be. If you were to ask some strangers in your environment which one of these out of the list is most disgusting that would set them off, you would get different types preferences of which ones that would trigger them. One individual would be triggered by leprosy, and maybe another person would be triggered by fried crickets and worms, and that would give them a disgust response that would tip them over the edge. The moral of the story is this mechanism of disgust is a multifactorial, and and especially what we find disgusting. Even though the response in the brain is more or less similar, there lies a general distinction. There is this similarity, but there is this intensity that we see in COCD patients. I just want to belabor this point because the difference between COCD and non-COCD person is generally the level of functionality in their interpretation. But going into a neurological explanation of this, neurotransmitter release. It's a different level of neurotransmitter release and alteration or dysregulation of neural pathways. In the end, we have to remember that with somebody with a disorder or not a disorder, we still have a finite organ. And whenever we have this finite system that is self-contained, if you tinker with one aspect of this finite organ, there are bound to be downstream effects to another part of that system. So as a normal person and normal functioning person, fried crickets and worms may set you off over the edge. But you can get back to baseline. But when you're set off over the edge for that small period of time, these other parts of your brain, it's not like they're not unaffected. It's not like it's an isolated event. So when we're investigating, what I would like to do, switch gears now, is to investigate what specifically the parts of the brain are being activated when a COCD patient is exposed to a disgust-based stimuli or signal. What parts of the brain are activated? When we're trying to answer this question, we can't answer it in an open-based system. We have to understand that the brain is a closed system, and these parts are interconnected. All these parts of the brain are interconnected. As an example, here's a good example of this. Let's say you were to pass gas on an elevator. You know, I'm not going to say that I've ever done that, but I've heard it's happened before, or somebody's in a crowded elevator and everybody's going to has to cope with it for the next 7 floors. And let's say that you are one brain, part of the brain, and these other people in the elevator are other parts of the brain. Even though you're the one that passed gas and you're responding a certain way, there's these other people that are, in this analogy, other parts of the brain that are going to do what they do, and they're going to respond the way they respond. And maybe they're going to be influencing you in some way. Maybe they're not going to like you after that trip on the elevator. Maybe they'll be a little bit aggressive. Who knows? But the moral of the story is these brain states are interconnected, and we're going to find that even though we're trying to isolate certain portions, there is this relationship with these other areas that will be left unexplained, will be left not explained. And so I'm going to set that caveat aside, and let's move on to the other parts of this. And when we're moving on to the other parts of this, we're going to kind of take on a different role now. We're going to imagine that we are detectives. I think that science does play the role as the Sherlock Holmes. I tend to have a bias towards Sherlock Holmes being a psychologist rather than a detective, or whatever the case may be, maybe criminologist. And so we're going to be looking at this $1 million question. What are the key players involved in COCD? We're going to investigate things like Sherlock Holmes and, excuse me, okay, and find out which areas are the key actors involved. COCD patients have this super anxiety-based response with this disgust signal. That means we need to dive into the brain and see the entire scene of the crime, or the entire scene of the events, or as much as we can. We're going to have like a spotlight rather than a floodgate, because we're in the darkness, and I think a better analogy is we have these flashlights. We're in the darkness and we're just flashing throughout this cave, and we're trying to